In this video, we will look at an example involving inverse trig and integration that needs to be done by substitution. So first, when I look at example 2, it may not seem obvious that this integral is going to match one of these forms, but one of the things that should stick out to you is the square root that's in the denominator. And the second thing that should stick out to you is the e to the 2x that's under the square root. Because I will point out that e to the 2x is the exact same thing as rewriting this as the square root of e to the x squared minus 1. And I know that I can rewrite it as that because rules of exponents would tell us to multiply the x and the 2 to get the exponent of 2x that we originally had. So we haven't changed the problem when we rewrite it this way. Rewriting it this way suggests that we should look at what happens when u is equal to e to the x, since that's what's on the inside of the parentheses being squared. Then differentiating would give us du is equal to e to the x dx. Now the issue here in this, if we try to do this substitution, is that we don't have an extra e to the x. All we have is that dx that's in the numerator. So I'm going to solve for that dx by dividing both sides of this equation by e to the x to get that dx is equal to du divided by e to the x. So I could replace this dx with this expression here, but when we do the substitution, we don't want to have any more x's in, so I don't want to replace that with that e to the x in that expression. So I'm going to use the fact that e to the x is the same thing as u. So we have du is equal to so we have that dx is equal to du divided by u. So now we can come in and do the substituting. We'll replace dx with du divided by u in the numerator, and then in the denominator we have the square root of u squared minus 1. Now I'm going to do a little bit of algebra. That du divided by u in the numerator, I will just point out that du divided by u is the same thing as 1 over u times du, and that 1 over u, I'm going to just write it with the u in the denominator in front of that square root. And now this integral looks very much like this integral, where our a value is equal to 1, since we are subtracting a 1 right there. So now we're ready to go ahead and start filling the right-hand side of this out and completing the integration. So we have 1 over a, 1 over 1, arcsecant of the absolute value of u, divided by a, which is just 1, plus c. And now I will simplify this and sub back in what u is. U is e to the x, so I have the absolute value of e to the x inside of this secant function. I will point out that I don't need absolute value there since e to the x is always greater than 0. So in this case, it would be fine to drop the absolute value bars and give that as our answer.